Hello everyone, today we'll talk about the solution to the problem minimum cost for tickets. This is quite a straightforward one-dimensional dynamic programming problem where we have a very simple recursive formulation for the cost to travel all the days based on cost to travel only some prefix of the days that were given. I don't think we have to talk about the solution before looking at the code is quite self-explanatory. The first thing that I'm going to do, and I recommend that you always try to think about it, is that here we're given days as a list of days when we're going to travel. However, for me, in this case, I felt that it would be more convenient to instead have a list for every day. So all the 366 days, starting from 0, the day 0 that we don't care about. And we mark in every day whether or not we travel then or we don't travel then. So at first it's all false, and for every day in the list of days that were given, we mark that we traveled that day. So whenever you have an input and you think that some other form of input would be more convenient for you, then it might be worth it to just convert it and don't worry about it anymore. Sometimes you even get some performance gains from it, but performance is one thing and being comfortable with implementing is another. And now let's see our one-dimensional dynamic programming. Again, we're using Python, so typically when it comes to DP, we can come up with the recursive formulation, write the recursive function, so in this case it's the function go, which will recurse again into itself. And when we use the cache decorator, this is the decorator that gives us memoization, we essentially convert this naive recursive solution into a dynamic programming solution. So we want to, in our function go, calculate the minimum number of dollars to travel every day up to some last day. So our result is just go of the last day that we can have. So 365. And now, how do we calculate that value? Well, first of all, if there are no more days to travel, so if last day is less than or equal to 0, we return 0. Otherwise, we have a decision to make. We can buy either pass that we want, and there is also, of course, a situation where we don't want to travel during that last day, and that situation is essentially the same thing as a one-day pass, because we still can buy a 7-day pass or a 30-day pass at that position. Maybe it's not ideal, or there are other ways of achieving an optimal solution, but if we find a solution, then we might as well buy a 7-day pass that ends on a day when we don't travel. So the version where we don't travel is the same as buying a one-day pass, but not for costs of 0, but just for $0. So essentially we have a one-day pass, which costs us either costs of 0 if we will travel, or is free. And that means that this day is covered, and we have to cover up to last day minus 1. So this is our recursion. Or we buy a 7-day pass, so it's costs of 1 plus go of last day minus 7, because now we have covered 7 more days. Likewise for costs of 2 and 30. Those are the 3 options that we have, and the minimum of those options is the cheapest way to cover all the days up to last day. Very easy recursive formulation, very easy, as usual in Python, to transform it into dynamic programming. And so we have a nice problem. And of course, if you prefer not to do this trick or this adjustment to convert the original array into this array of will travel, of this array of booleans, then feel free to do so and think about how this solution will change.